All right, so this was more of a middle of the road score. Now, first thing we're going to recognize is these trig functions or these trig identities are not correct. So again, you noticed in that last one, they wrote out o squared plus a squared equals h squared and derived them from that. Right? If you just try to memorize them, you may run into an issue of ending up with the wrong trig identities, which can cause a problem later on. Now, I think it ended up being okay for them in number 2. Let's zoom in on that. So they actually did this nice thing where they said sine squared is 1 minus cosine squared. And then we don't even have to do anything with tangent squared because look, we have a minus sign. We want a minus sign because there's a minus sign in the end. If we just distribute tangent, we're going to get tangent squared times 1, which is right there, minus tangent squared times cosine squared. And that's good because tangent is sine over cosine, so the cosines are going to cancel and boom, we're already done. We have tangent squared minus sine squared in basically 2 steps. Now, the interesting thing here is that it didn't show up well in the scan, but I was actually able to see that this person had written stuff and erased it. And I said, looks like you had it. It looks like they were on the right track, but they erased it. Okay, so a lot of this actually was a big problem on this test. Don't erase. You could get at least another half point, or you could get a full point. I'm not going to judge you for your answer, but I certainly can't help you out if you erase it, right? So just keep your answer, be confident, and I think in this case, this person may have gotten 1 point, or even a half point, or even 1 point. So again, did a great job on this angle conversion. Sweet job there. And then this is where I think they ran into some problems with the wrong trig identities because they said secant squared minus 1 was cosecant squared when it should have been tangent squared. And then this was another problem. A lot of people either tried to do tangent squared over cotangent squared cancels, or in this case, this person did cosecant squared over 1 over cosecant squared cancels. But this is the issue with that. So if I know tangent squared times cotangent squared equals 1 because they're reciprocals, then I can't also say tangent squared over cotangent squared equals 1, right? There's no way that both of these statements are true. Same thing here, I can't say cosecant squared over sine squared is 1 because cosecant squared times sine squared is 1. So both of those statements can't be true. And then, so they have cosine squared over sine squared, so then they canceled the cosine squareds and then said 1 plus sine squared is cosine squared. And again, if we say sine squared plus cosine squared equals 1, then it can't also be true that 1 plus sine squared equals cosine squared. If we isolate for cosine squared, we get cosine squared equals 1 minus sine squared. So I threw them a couple half points. They were able to do the cotangent squared over cotangent squared times tangent squared is equal to 1. They did a good job of trying to cancel stuff and using the identities that they thought were correct. So I didn't want to double count them wrong for always using the wrong identities, but couldn't give them more than 1.5 here. Okay, we got to move on to the second page now. Okay, so they did a great job on the first one. 1 second, let me erase this stuff. They did a great job on the first one. They got plus or minus root 3 over 4. I think I'm just seeing now that they put 4 instead of 2. But again, sometimes I'm kind of lenient on this because I know what they meant because they got the correct pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. They did the correct restrictions. And then I think they just forgot root 4 is 2. I mean, they clearly had an idea of plus or minus root 3 over 2 because they got the correct angles. So I let that one slide. But then here is an example of what happens when you try to cancel the cosine. So basically what happened is they added 2 cosine theta over root 3 to the other side, and then see how they canceled the cosine? So it's only cosecant theta equals 2 over root 3. Well, we saw in the last video what happens then. We only get 2 of our answers, but it turns out that if we plug in the answers for cosine theta equals 0, if we were to plug in pi over 2, for example, we get 0 minus 0 equals 0. So that would be another 0 of this function that we cancel by canceling the cosine thetas. It would be kind of similar. I'm trying to decide if I want to show you this right now. No, that's cool. Like I'm just going to let that go for now. It's kind of a weird algebra thing. But a lot of you ran into that issue. Instead, factor out the cosine theta, and then you have 2 factors. And then they also ran into the issue of trying to FOIL out this mess, which was horrible. I'm so sorry any of you had to go through that, because it ends up being kind of nasty and doesn't really lead you to a good place. So again, I emphasized it's already factored for you. Just set each factor equal to 0. Okay, so here they only got one of the intervals where f is increasing. They said that f prime is positive from 0 to 2 pi over 3. But then it's also going to switch back to being, so 2 pi over 3 to 4 pi over 3, f prime is negative, but it switches back to being positive on this interval. So I took out 1. They tried to show their thinking here. But I even see that it looks like they were trying to show that it was also positive down here, but I just can't see that from their interval here. So that was my addition right there. And then down here, they said pi over 2 to pi and 3 pi over 2 to 2 pi. But we know that it's actually just pi to 3 pi over 2 and 3 pi over 2 to 2 pi. So we can see from pi over 2 to pi, that's from here to here. Again, that's where, for example, that's where we could run into the issue of having a positive 1/2 minus 1 over 1/2, since the reciprocals, which is negative 1.5. Which again, if the derivative is negative, then that means that the function can't be increasing. So this one's no good. So I took off a point for including that interval and also not having that it was increasing from pi to 3 pi over 2. We'll look at this graph now since we didn't do it in the last one. So the frequency we recognize as this number. So they said 0.5. The period's 2 pi over 0.5, which is 4 pi. You can also say 0.5 means you do half a cycle every 2 pi, so a full cycle every 4 pi. And then they split it up. They split their 4 pi into the 4 sections of the unit circle. So we have, this would be quadrant 1, quadrant 2, quadrant 3, quadrant 4. Remember, cosine's positive in quadrant 1 and quadrant 4, negative in quadrant 2 and quadrant 3, so that reflects here. And then they have an amplitude of 4, so it goes from 4 to negative 4. So this is beautiful. And then let's talk about this. Remember, some of you focused on these maxes and mins right here. But that's the max and mins of f prime. That's where f prime is increasing or f is increasing or decreasing at the fastest rate. Where we have maxes are where f prime is 0, and where we have mins is where f prime is 0. So from here, we go from positive to negative, so we go increasing to decreasing, that's a max. Here it goes negative to positive, so that's decreasing to decreasing, so that's a min. All right, and that's it. So this was more of a middle of the road. They missed like 7.5 or 8 points on this, but still a pretty